In this lecture, we'll be seeing 0-1 programming problem and balanced implicit enumeration algorithm for solving 0-1 programming problem. 0-1 programming is a very critical area in decision making. In 0-1 programming problem, value any variable can take is either 0 or 1. Yes or no, true or false. Such decisions are very important as the choice is from only two values. Sometimes series of answers to many such questions lead to decision to be executed finally. For example, which player should play at which of 11 batting position is answered by a collection of questions whether a player I will bat at position J or not. Like in cricket team, there are 11 players and 11 batting positions. So there will be 11 into 11 variables, that is 121 variables, and these variables will be taking value 0 or 1, and finally this will be answering, this collection of questions will be answering which player will be batting at which position. Such problem can be solved by using explicit enumeration algorithm, that is trying all possible combinations of solution. Another approach is implicit enumeration algorithm, that is intelligently filtering out those combinations which do not lead to optimal solution. In this lecture, we will be learning balanced implicit enumeration algorithm. Here we go. The problem. Maximize z equal to 5x1 minus 7x2 minus 10x3 plus 3x4 minus x5 subject to x1 plus 3x2 minus 5x3 plus x4 plus 4x5 less than equal to 0 is the first constraint. Second constraint is 2x1 plus 6x2 minus 3x3 plus 2x4 plus 2x5 greater than equal to 4. And third constraint, x2 minus 2x3 minus x4 plus x5 less than equal to minus 2. And all the variables right from x1 to x5 are 0 or 1. If we were required to solve this problem by explicit enumeration algorithm, then as we know that each of the variable can take value 0 or 1 and there are 5 variables, so the number of combinations of the solution string will be, our solution set will be 2 to the power 5, that is 32. Some combinations out of this 32 combination will be violating some or some of the constraints, some of the 3 constraints, right? Those combinations will be discarded out, and the combinations which satisfy all the constraints, for those combinations only value of z will be found. And lastly, by comparing the value of z to find the maximum value of z will help you in getting the optimal solution. That's a very simple approach, but it consumes a lot of time of the computer getting you the optimal solution. For 5 variables, it won't take that much of the time, but unfortunately, the number of variables involved in such problem are thousands. Okay, so using explicit enumeration algorithm is not a wise proposition for solving 0-1 programming problem, because in that case the number of combinations you will have to try will be 2 to the power 1000 or more. So that becomes very enormous number. So therefore we will be saying how to solve such problems by implicit enumeration algorithm. So for solving the problem by implicit enumeration algorithm, some pre-processing of the problem needs to be done that requires you to have your objective function of minimized type. And second requirement is all the terms in the objective function must have positive coefficient. And the third requirement is that all the constraints are to be transformed to type greater than equal to 0, right? This is very normal and we are not doing anything unreasonably. Everything we are doing has some reason behind it. We are not just doing it, okay? And as we go through the process, you will understand why at all we are having the objective function minimize, we are converting the objective function to minimize type, why all the terms in the objective function we are converting to positive, and why all the constraints are transformed to have their right hand side of the form greater than equal to 0. So first of all, for converting our objective function from maximize to minimize, if it is already minimized, then you don't have to do anything with that as far as conversion is concerned. But here the objective function is maximized, so for converting it to minimize, we will be multiplying this objective function by -1. So I get equivalent equivalent minimized type of objective function in the form of minimize z dash is equal to -5x1 plus 7x2 plus 10x3 minus 3x4 plus x5. But now, second condition, if we look at, we are having our objective function minimized, but the terms in the objective function are not all positive. Some of the coefficients are negative, right? So, for converting these coefficients to positive, I will need to make a substitution of the form like here x1, because the coefficient of x1 is -5. For converting that -5 to +5, I will be substituting x1 as 1 minus y1. Now you may ask the question, why not simply minus y1? If I substitute x1 as minus y1, then if x1 takes value 0, minus y1 will be taking value 0. It's fine. But if x1 is 1, then y1 will be -1. That I don't want. I want a substitution of a kind wherein I am sure that variable I am using in my substitution will also be taking value 0 or 1. So in this substitution, when I am substituting x1 by 1 minus y1, what is happening? Just look. If x1 is 0, if I suppose say if y1 is 0, x1 will be 1, and if y1 is 1, x1 will be 0. That's good, because my variable x1 is taking value 0 or 1, y1 also is taking value 0 or 1. Okay. So the variable which has negative coefficient is to be substituted by 1 minus yi, here in this case y1. Now there is another variable which has negative coefficient here x4, so I will be substituting that by 1 minus y4. x4 I will be substituting it by 1 minus y4. Now for avoiding a situation wherein some variables are in form of y's and some variable are in form of x, I am substituting other x variables to y variables, like even though that is not required to be done, but to have homogeneous base variable, I will be substituting x2 as y2, x3 as y3, and x5 as y5, so that I have my objective function in terms of y's only. Alright. So now the objective function becomes 5y1 plus 7y2 plus 10y3 plus 3y4 plus y5, and that one part minus 5 from here and minus 3 from here is coming here in the form of -8. That you may continue to have it in your objective function, or you may eliminate it. Okay, you can have this whole as your objective function, or you can have your objective function till y5, right? I hope you have understood that. Now that I have transformed my objective function to a minimized type and to have all the coefficients with to have all the positive coefficients in the objective function, I now have to see that all my constraints are transformed to greater than equal to 0 form. All right. So I will be doing this substitution in the constraints also. X1 substituted by 1 minus y1. All right. So just look at it. X1 substituted by 1 minus y1 plus 3y2 minus 5y3. X4 substituted by 1 minus y4 plus 4x5 substituted by 4y5 less than equal to 0. Right, this is simplified to this form, again less than equal to 0 here, but I want the constant in the form greater than equal to 0, so I have changed all the signs here. For example, minus y1 to y1 plus 3y2 to minus 3y2 minus 5y3 to plus 5y3 and so on. All the coefficients I have changed, thereby I have converted this less than equal to 0 type constraint to greater than equal to 0 type constraint. Again, by substituting these things, x1 as 1 minus y1 and x4 as 1 minus y4 and rest other as x2 equal to y2, x3 equal to y3 and x5 equal to y5 in the second and third constraint and doing necessary transformations to get the constraint converted to type greater than equal to 0, I convert the constraint as I am saying. Okay, you can do it yourself and confirm whether your transformation is leading to get your constraint transformed to this form and this form. Right. Finally, if I compile my problem together, this is the objective function till this, which is to be in the form of minimize, and the first constraint taken from here greater than equal to 0 form, second constraint again greater than equal to 0 form, and third constraint greater than equal to 0 form. So all these pre-processing conditions, three conditions, I have taken care. Now the question is, why at all I want minimize type of objective function? Why I am not interested in having my objective function maximize type? So if it is maximize type, I don't know what is the best value of this objective function, or it will be varying value. Okay, if my objective function is maximize type, then the best value of objective function will be a varying value depending upon the problem. But if I have my objective function minimize type, and if I make sure that all the terms in the objective function have positive coefficient, the best solution will be 0. All the variables involved in the problem will be taking 0 value, and z value is 0. So if I get 0 solution, value of z equal to 0, that itself is the optimal solution. But the problem is, my constraint may not get satisfied with that kind of solution. If that happens, if my constraint gets satisfied, fine. Okay, I get the solution before I do much in the much of the processing, right? So the constraints now, why I have converted the constraint to greater than equal to 0 form, because soon this value comes positive, it will be very sure to me that the constraint is satisfied. If this value is negative, then it will be very sure to me that the constraint is violated. Otherwise, I will have to compare the left hand side with the right hand side to assess whether the constraint is satisfied or violated. Now, simply by seeing if the constraint has positive or 0 value, then it is satisfied, right? And if it is if it is what you say negative value, then it is violated, right? So now that we are having the pre-processed problem available to us, we are ready for applying implicit enumeration algorithm, Bayes' implicit enumeration algorithm. So let's move on to the next transparency. All right. Now we have here the problem is written for our ready reference, right? Now we don't know which variable will be taking which value of 0 and 1. So all the variables for us at the beginning are pre-variables, and we collect them in preset. And here I have written 1, 2, 3, 4, 5. That means y1, y2, y3, y4 and y5 are pre-variable. They are free to take any value. And in fixate, I have not fixed any variable to some specific value, right? So in fixate, there is no variable. It is a null set. If objective is minimization, then if the constraint permit, we will like to have as many variables as possible set equal to 0. We are saying because our objective function is minimized. So as many variables from this objective function take value 0, it will be better solution, right? So assuming that all pre-variables are 0, because we have not fixed any value for any of the pre-variables, and that's why they are pre. So assuming that all pre-variables are equal to 0, we will be finding the value of C1, C2, C3. C1 is the first constant left hand side, C2 is the second constant left hand side, and C3 is the third constant left hand side. So C1's value by putting all pre-variables equal to 0 is -2. C2's value comes out to be 0 and C3's value comes out to be -1. So we are seeing that because C1's and C2's value is C1's and C3's value is negative, we say that the constraint is first and third constraint is violated, right? So when they are violated, we will have to look into the possibility that if it is at all possible to satisfy the first and third constraint. Second, we are seeing that it is already satisfied. So for checking the possibility of feasibility of first and third constraint, what we will be doing, all the variables, we will be substituting all the variables in first constraint, for example here, from preset, but have positive coefficient in the first constraint, will be substituting them as 1. That is the only way of converting this minus sign to plus sign. All right. So we will be substituting y1 because it belongs to preset, then y3 and then y4. Okay, all these variables belong to preset. We have substituted them equal to 1 because they have +1 coefficient. Rest which have negative coefficient, we are not substituting them as 1. So what I am getting, 1 plus 5, 6 plus 1, 7. Am I right? Am I right? Yes, see here I am having a mistake, but that is not affecting another part of the solution. C1 turns out to be 7. So it is possible to satisfy the first constraint. In place of 5, you read there 7. Now, third constraint which was violated, we want to look into the possibility of satisfying the third constraint. So for that, what we do is from the preset, which has right now all the variables, we will be substituting only those variables equal to 1 which have positive coefficient in third constraint. So y3 only has positive coefficient in third constraint. So we'll be substituting y3 equal to 1, and after that this becomes 2 minus 1, that gets you 1 value of C3. And as it is possible to get the positive or 0 value of C3, there is a possibility of satisfying the constraint. So having known that it is possible to satisfy the constraint, we will proceed ahead towards fixing one of the 5 variables from preset to 1. Right? Now suppose say at this stage itself, you would have found that it is not possible to satisfy the constraint. Here itself, you would have got the solution that the problem doesn't have solution. Alright? So now that we have got the positive result for the test for possibility of feasibility, we will be moving towards fixing one of the variable out of this 5 to equal to 1. So we will be doing it one by one. I will be fixing y1 equal to 1. While I fix y1 equal to 1, rest other I am free to assume them equal to 0. Okay. Now here I am using a term called a distance from feasibility. What does that mean? It means how far you are from, how much away you are from feasibility. If you are getting a feasible, you are satisfying certain constraint you are dealing with, then your distance from feasibility will be 0. But if it is coming negative, if your constraint is getting violated, adding how much quantity to it will satisfy the constraint is the distance from feasibility, right? So distance from feasibility for C1, for C2 and for C3 will be finding, and then lastly will be finding total distance from feasibility, right? So y1 equal to 1, I am substituting y1 equal to 1 in first constraint, and rest other are 0. So 1 minus 2 is getting me minus 1. So the constraint is violated, but if I add 1 to it, it will get satisfied. Right? So their distance from feasibility is 1. Now let us look at distance from feasibility for second constraint. If y1 is substituted equal to 1, so this is becoming minus 2, and there is no other addition. So minus 2, all other are 0. So minus 2, the distance from feasibility for this constraint in that case is 2, because the constraint is violated, and if I add 2 to it, the constraint will become satisfied. So distance from feasibility for second constraint is 2, and for third constraint y1 is not there, term is not there, and others I am assuming all of them equal to 0, and minus 1 is there. So if I add 1 to this, then only it will be possible for me to satisfy third constraint, right? If the value of left hand side comes negative, then the absolute of that is the distance from feasibility. If it comes positive, then the distance from feasibility is 0, because the constraint is already satisfied. Now if I take y2 equal to 0 and rest all other equal to y2 equal to 1, rest all other equal to 0. So here I get minus 3, minus 2, minus 5. That means 5 distance away. C1 is 5 distance away. And C2 now. Y2 I am taking equal to 1. And rest other 0, 6. So left C2 will become equal to 6. So distance from feasibility in that case is 0, because the constraint is already satisfied. Right? Then third one, y2 equal to 1 I am substituting, so this term will become minus 1, or rest all variables are 0, minus 1, minus 1, minus 2. So distance from feasibility is 2. So total distance from feasibility is 7. It is addition of the distances from feasibility. Likewise, by substituting y3 equal to 1, y4 equal to 1, y5 equal to 1, while I do this substitution, rest other variables I am assuming 0. So you can yourself find these values and the total distance from feasibility. Now I'll be comparing total distances from feasibility to find the minimum total distance from feasibility, and that is 3. So I'll be fixing y3 equal to 1. Okay. Now I'll be going on to the second iteration. Okay. My iteration ends here. Second iterations. Okay. Now in my fixate, I have one value which was null here. Now I have one value 3 because I have fixed y3 equal to 1. And that value will not be there now in preset. So my preset has 1, 2, 4, 5 values, right? Now once again I'll be substituting, or I'll be assuming all pre-variables equal to 0, y3 equal to 1 because it is fixed. And I will be finding out the values of C1, C2 and C3. Just look here. Y3 I have fixed equal to 1 and rest all other are 0. So 5 minus 2 is 3. So that means that constant C1 equal to 3. When C1 comes positive, it is indicative of constraint getting satisfied. Now second constraint. Now y3 equal to 1. And rest others 0. Alright. So 6. It is 6. Sorry. It is 6. It is 6. Just a minute. Y1 6. Sorry. Y3 is 1. So it is minus 3 and rest all other are 0. So minus 3. C2's value is coming out to be minus 3, and having that value negative is indicative of violation of the constraint. And then let's go on to the third constraint. Y3 is equal to 1, rest all other are 0. So I am getting the value of C3 equal to 2 minus this 1. 2 minus this 1 makes it 1. Okay, here it should be 1, but if it is 0 or 1, both are indicative of satisfying, both are indicative of satisfaction of third constraint. So all in all, considering this mistake also, we are seeing that second constraint is violated. Now the question is it at all possible to satisfy second constraint? Right? For that, what we'll be doing, from this preset, whichever variable have positive coefficient in the second constraint, because second constraint, why? Because we are concerned with it being violated constraint. In the second constraint, I am finding that coefficient of y2 is positive and y5 is positive. Both of them are in preset, so I can substitute their coefficient equal, their value equal to 1. So 6 plus 2, 8. Okay. Minus 3, because y3 is fixed equal to 1. So it is coming out to be 5. So as this is 5, the constraint can be satisfied. Now having signaled that it is possible to satisfy second constraint, violated constraint, we will move on to fix one more variable equal to 1. We already fixed y3 equal to 1. Now we are moving towards fixing some other variable equal to 1. All right. Now, feasible solution is obtained, but it is not optimal. I don't know whether it is optimal or not, but feasible solution, definitely yes. So by now, if I track the process, first I have fixed y3 equal to 1, and then I have fixed y2 equal to 1, and there I have got a feasible solution, and soon I get the feasible solution, I'll be finding the value of z. So by substituting y2 equal to 1 and y3 equal to 1, I get z equal to 17. Okay. For getting the optimal solution now, I have the standard or minimum known value of z is available with me. If I get any other value of z which is less than 17, then I will be referring to that value of z as being a minimum value for any later endeavors. I will then be trying to get the value of z lesser than that minimum value of z. That's what is the idea. Now that I have tried y2 equal to 1, I would like to go back to this node and I would like to try another path. Another path means y2 equal to 0. So what this process is called as backtracking. So I am going back and taking another path. So I now have the fixations of the variable as y3 equal to 1 and y2 equal to 0. So my fixate is indicated as y3 equal to, as 3 and minus 2. Now this minus 2 is used for signifying that the variable corresponding to that minus sign is taking value 0. Okay, y3 is 1 and y2 is fixed equal to 0. Not assumed equal to. y3 is fixed equal to 1, y2 is fixed equal to 0 because it has minus sign, right? And now my presets is having the variables which are not there in fixed 1, 4 and 5. Now here, when I was going along this path, I know that I am not going to get a feasible solution at this point. But still, what I am doing, I'll be finding the value of z tentative which gets built till this point by taking y3 equal to 1 and y2 equal to 0, right? y3 equal to 1 and y3 equal to 1 and y2 equal to 0, and rest other safely assumed to be 0. So tentative value of z so far built is 10. Now I would not like to have any other variable fixed equal to 1 which has the coefficient greater than 7. Because when I know that value of z I have built so far by fixing these two variables the way I have fixed is coming out to be 10. Minimum known standard of z is 17. So I have the scope of 7, right? 17 minus 10. I won't allow any variable to be fixed equal to 1 if it has a coefficient greater than 7. So from my preset, I will eliminate those variables which has coefficient greater than 7. So I will be checking the coefficients of y1, y4 and y5 in objective function. Are they greater than 7? And if they are, I will omit them from being the member of preset, and that's how I build what is called as modified preset. So y1's coefficient is 5, less than 7. y4's coefficient is 3, less than 7. y5's coefficient is 1, less than 7. So my modified preset is preset itself. Sometimes you may have all the elements from the preset which will be having value of z, which will be having the coefficients in objective function greater than scope. In that case, modified preset will become null set, right? Now, uh, I will be finding out, now the iterations are same except for this addition thing here. Constant state I will be finding by setting pre-variables from modified preset equal to 0, right? So, and y3 fixed equal to 1, y2 fixed equal to 0, and y1, y4 and y5 assumed equal to 0, I get c1, c2 and c3 as 3, minus 3 and 0. Okay, right? 3, minus 3 and 0. So, second constraint is violated. So again, I will be carrying out the test for possibility of feasibility on the second constraint. Now just look at this, right? Now just look at this, just a second. Just look at this. What I am having? C2 is violated, and I will be fixing. I know that y3 is 1, so minus 3 is fixed. Okay, y2 is equal to 0. Okay, I don't have option of putting that y2 equal to 1. So by these two terms I am having value minus 3 built so far, right? And now from preset, which includes modified preset y1, y4 and y5, I need to find if any of the variables have positive coefficient. Okay, so y5 has positive coefficient. All right, 2, right? Minus 3 plus 2 gets you minus 1. So what does that mean? It means that it is not possible to satisfy second constraint. Okay, feasible solution cannot be obtained by combination in which y3 is 1 and y2 is 0. Okay, so this node means if I am trying to investigate this path for optimal solution, that path gets terminated here itself, because along this path if I go, I am not going to get a feasible solution. That is confirmed by the test for possibility of feasibility. Okay, now that this branch is not going to yield me anything constructive, so I will be going further back where I have tried y3 equal to 0. I want to try y3. I have tried y3 equal to 1. I want to try y3 equal to 0. Okay, so my fixed set in this iteration now will be minus 3, because I am going along this path minus 3, and the pre-variables for me now are 1, 2, 4 and 5. Now look at this. I have the idea of minimum value of z, that is 17, and tentative value of z getting built because of the variables I have fixed so far, that is y3 equal to 0. And if I substitute here in the objective function, what is happening, z tentative is coming out to be 0. The scope I am having of increasing the value of z is 17 minus 0, that is 17 scope is there. So if any of the variable from preset is having coefficient greater than 17, I will be eliminating that variable from preset. That's how I'll be getting modified preset. All right, and then going on to continuing that iteration, I am going to find C1, C2 and C3. But while doing that, I need to keep in mind that y3 is fixed equal to 0 and others are assumed equal to 0. So I am getting the value of C1 as -2, C2 as 0, and C3 as -1. All right. And I'll be performing the test for possibility of feasibility. All right. On the first and third constant which are violated. So just look here. Y3 I cannot take it as 1 because I have fixed equal to 0. So let's consider constant number 1 for checking if at all it can be satisfied or not. Right? So I have y1, y2, y4 and y5 in modified preset, but only out of those y1 and y4 has positive coefficient. Like I'll be substituting them as 1. Alright. So 5 plus 1, y3 is 0. 1 plus 1, 2 minus 2 is equal to 0. Alright. Third constraint. Right. Y3 is 0. And I don't have any variable from modified preset which has positive coefficient in constraint number 3. So I am going to get C3 as C3 y3 is fixed equal to 0, and C3 I am going to have is -1. By mistake here it is -2. It should be -1 only. All right. So all in all, that means I am not able to satisfy third constraint. It's not possible to get a feasible solution if y3 is fixed equal to 0. That is sure. So I don't have to try any combination wherein y3 is equal to 0, because that is not leading me towards getting the optimal solution, right? So it's not possible for you to get a feasible solution if y3 is equal to 0. So everything has been searched so far. So my solution is y3 equal to 1, y2 equal to 1. Okay, because amongst all the possibilities, all the combinations I have tried so far, this only has given me the optimal solution, feasible solution, and that eventually happens to be optimal solution, right? Y3 1, y2 1. So y1, y4 and y5 equal to 0, right? But if you recall back to the substitutions you have made in the beginning, y1 is 1 minus, x1 is 1 minus y1. So as y1 is 0, x1 will be 1. y2 is x2. So as y2 is 1, x2 is 1. y3 is x3, y3 1, x3 1. y4 is equal to 0 means x4 is equal to 1. And y5 is x5, so y5 is 0 means x5 is 0. And by substituting all these variables in the original problem, I am getting z equal to -19. Now you may question that when the problem is same, then why in this case I am getting z minimum as 17 and z minimum as 17, and here for the original problem z as -9, because if you recall I was subtracting -8 in the original problem, which I have not done. If I do that, then z will come equal to 9. if you recall one more thing, that for converting your objective function from maximize to minimize, we have taken we have used or we have multiplied the objective function by -1. So here we are getting it -9, and there it is 17 minus 8 means 9 only. Both the answers are same, right? This is how we will be using balanced implicit algorithm. Here the problem got easily finished, but sometimes the problem may grow. There are branches on this side, and that branches may have to be backtracked once again, and further sub branches may also have to be backtracked, and in that case the problem shows a little bit of complexity. Okay, so here we finish our lecture. However, you are supposed to take up the same problem, and as you will be moving through the solution, you also do the solution yourself. Thank you so much.